Hello guys, welcome to Makaut Smashers and also welcome to the journey into the heart of embedded system technology. The embedded system, the silent heroes behind the devices we rely on daily are everywhere from your smartphone to your car's engine control unit. In this video, we will demystify the world of embedded system, exploring their design, programming and real-world application. Get ready to dive into the intricacies of microcontroller architecture, learn about tools used by developers and discover the exciting future trends shaping this field. So join us as we uncover the inner working of these tiny yet powerful systems that drive innovation in countless industries. So at first, the introduction to embedded system. Embedded systems are specialized computing systems designed to perform the specific task within the larger system or devices. Unlike general purpose computers, which are versatile and capable of running a wide range of applications, embedded systems are purpose built to handle the particular functions efficiently. They are typically found in everyday devices and systems such as automobiles, household applications, medical devices, industrial machinery, and consumer electronics. So, embedded system engineering involves designing, developing, deploying these systems while considering the factors such as performance, reliability, cost, and power efficiency. It requires a multidisciplinary approach, incorporating knowledge from fields such as electrical engineering, computer science, and software engineering. So, overall, the embedded system play a vital role in the modern technology, enabling the functionality of countless devices and systems that we rely on in our daily lives. So now it is time to discuss about the basics of embedded systems. The embedded systems are fundamental to modern technology, the powerful or powering everything from household applications to complex industrial machinery. So at first, the components used in embedded system like at first microcontroller or microprocessor. Okay, so we should now discuss about the what is microcontroller and microprocessor. So these are both essential components used in embedded system, but they serve different purposes and have distinct characteristics. So at first, microcontroller. A microcontroller is a compact integrated circuit that includes a CPU core, memory, input-output, peripherals, timers, and sometimes analog to digital converters (ADC) and digital to analog converter (DAC) on a single chip. So what is the purpose of microcontroller? The microcontrollers are designed for embedded applications that require control and real-time operation. They are commonly used in applications where cost, power, consumption and size are critical factors such as consumer electronics, automotive systems, industrial automation and IoT devices. So it typically operates on low clock speed, integrated peripherals for interfacing with external devices and sensors. Okay, so some examples of microcontroller like ATML, AVR, microchip PIC, ARM, Cortex MCDs, okay, etc. Number 2 is about microprocessor. A microprocessor is a central processing unit chip that focuses solely on processing data and executing the instructions. It requires external support components such as memory, I/O interfaces, peripherals to function as a complete computer system. The microprocessors are used in systems where flexibility, computational power and multitasking capability are paramount. They are commonly found in general purpose computing devices like desktop, computer, laptop, server and high performance embedded systems. Okay, so in summary, the microcontroller are integrated chips designed for specific embedded applications, offering low cost, low powering solution with integrated peripherals and real-time capabilities. On the other hand, the microprocessor provide the higher computational power and flexibility, but require additional external components to function as complete systems. So the choice between a microcontroller and a microprocessor depends on the specific requirements of the embedded application, including the performance, the power consumption, cost and the need for the real-time operations. So now the important terminology used in embedded system like RTOS, the real-time operating system. The RTOS are specialized OS designed to manage the task with strict timing requirements in embedded system. Unlike the general purpose operating systems such as Windows or Linux, RTOS prioritize predictability and deterministic behavior, making them ideal for applications where the timely responses to external events are critical. So why RTOS are commonly used in embedded system like deterministic behavior, task scheduling, interrupt handling, the resource management, the low latency, concurrency and synchronization. Okay, so overall the RTOS play a crucial role in enabling the development of real-time embedded systems by providing the necessary tools and mechanisms to meet the stringent timing requirements and ensure the reliable operation in a variety of applications. So now it is time to discuss about the embedded system design process. The design process for embedded systems involves several stages, each crucial for ensuring that the final product meets its requirement efficiently and reliably. So now we will use the concept of software engineering in this field. Okay. At first, the requirement analysis. So at first, they define the functional and non-functional requirements of the embedded systems, including its intended purpose, the performance criteria, the power constraints, size limitations, environmental conditions and regulatory standards. Okay, so number 2 is about the system architecture design. So develop a high level system architecture that outlines the components, interfaces and interactions of the embedded system. Okay, so number 3 about the hardware design. So design the hardware components of the embedded system, including the schematic diagrams, printed circuit board, PCB layout and bills of materials. Okay, number 4 is about the software development. So we can write and debug the software components of the embedded system, including the firmware, device driver, the real-time OS if applicable and application softwares. Number 5 is about the integration and testing. So integrate the hardware and software components to form the complete embedded system. So we can conduct some system level testing to validate the functionality, the performance and reliability under the normal operating conditions, as well as corner cases and failure scenarios. Number 6 is about the verification and validation. So we can verify that the embedded system meets the functional and non-functional requirements defined during the requirement analysis phase. Number 7 is about the deployment and maintenance. So we can deploy the embedded system in its intended environment, whether it is a consumer product, industrial machine, automated system or IoT devices. Okay, so throughout this design process, it is essential to follow the best practices for design automation, version control, risk management and quality assurance to ensure the successful development of the embedded system. Collaboration between the multidisciplinary teams, including the hardware engineer, software developer, firmware engineer and domain experts, is also critical for achieving the project goals effectively. Now it is time to discuss about the microcontroller architecture. Okay, so microcontroller architecture refers to the internal organization and structure of a microcontroller chip, including its CPU code, memory, I/O peripherals and the other key components. At first, the CPU code. So the CPU code is the primary processing unit of the microcontroller. It is responsible for executing the instruction and performing the computations. Okay, so number 2 is memory. So we have various type of memory in microcontroller like program memory, ROM or flash, data memory or RAM, or some microcontroller may also include additional memory types such as EEPROM, electrically erasable programmable read-only memory, for storing the non-volatile data that may need to be modified occasionally. Number 3 is about the I/O peripherals. So microcontroller features various input-output peripherals to interact with external world like GPIO, general purpose input-output, timer and counters, communication interfaces, analog to digital converter, digital to analog converter. Okay. Number 4 is interrupt controller. Microcontrollers feature an interrupt controller that manages the interrupts from the internal and external sources. Clock and power management. Microcontrollers requires an internal clock source to synchronize the operation of the CPU and the peripherals. Okay, so number 6 is debugging and development features. Okay, so understanding the architecture of a microcontroller is essential for designing and developing the embedded system effectively. It helps developers to make informed decisions about the hardware selection, the software development, the memory management and system integration. Additionally, familiarity with microcontroller architecture enables efficient troubleshooting, optimization, and performance tuning during the development process. So now it is time to discuss about the programming in embedded system. Programming in embedded system involves developing the software that runs on microcontrollers or microprocessors to control the behavior of the embedded device and interact with its peripherals and external environment. So at first we need to choose a specific programming language and understand the hardware, the peripheral initialization, the configuration, and writing the application code. Also we need to learn about the memory management, the real-time consideration, testing and debugging, power optimization, and deployment and maintenance. So programming in embedded system requires a solid understanding of both hardware and software components, as well as the proficiency in the chosen programming language and development tools. Collaboration with hardware engineers, system designers, and domain experts is often necessary to develop robust and reliable embedded system software solutions. So several programming languages are commonly used in developing embedded system, each with its own advantage and sustainability for specific applications. At first we need C programming language. C is the most widely used programming language for embedded system development due to its efficiency, portability, and close to hardware capabilities. It allows the direct access to memory and hardware registers, making it suitable for low-level system programming. The C++ extends the capabilities of C with features such as classes, inheritance, polymorphism, and templates, making it suitable for object-oriented programming in embedded systems. It offers better code organization, reusability, and maintainability compared to C, especially for the large embedded projects. Number 3, assembly language. Assembly language provides the most direct control over the hardware resources and is often used for writing the low-level code in embedded system. It allows the programmers to optimize the code for performance, the memory uses, and power consumption by manually manipulating the processor instruction and registers. Number 4, Python. While less common than C and C++, Python is gaining popularity in embedded systems by using MicroPython. Python can be integrated with C and C++ code using the libraries like MicroPython or running Python interpreters on microcontroller with sufficient resources. So Python's simplicity, the readability, and extensive library support make it suitable for rapid development and prototyping of embedded systems. So now it is time to discuss about the application of embedded system. Embedded systems are ubiquitous and play a vital role in various industries and contributing to the functionality and automation of numerous devices and systems. At first, the automotive systems. Engine control units manage fuel injection, ignition timing, and emission control in modern vehicles, improving the fuel efficiency and reducing the emission. Advanced driver assistance system provide the features like adaptive cruise control, collision avoidance. Okay. So number 2 is about the consumer electronics. Smartphone, tablets, wearable devices incorporate embedded systems to provide the functionalities such as communication, multimedia, playback, sensor, accelerometer, and GPS and user interfaces. Smart home devices including the thermostats, security cameras, door locks, and lighting controls use the embedded system for the home automation and remote monitoring. Number 3, industrial automation. Programmable logic controllers, PCLs, control machinery and processes in manufacturing plants, warehouses, and industrial facilities, improving the productivity and efficiency and safety. Supervisory control and data acquisition, SCADA systems monitor and control the industrial process, utilities, and infrastructure, providing a real-time data visualization and remote control capabilities. Number 4, medical devices. Embedded systems are used in medical devices such as pacemakers, insulin pumps, patient monitors, and diagnostic equipment for monitoring and treatment and diagnosis of medical conditions. Number 5, telecommunication. Networking equipment including the routers, switches, modems, and base stations use embedded systems for data routing, packet switching, protocol handling, and network management. Number 6, aerospace and defense. Number 7, IoT. So these are just a few examples of the wide range applications of embedded system, highlighting their performance and importance in modern technology, and society. As technology continues to advance, the embedded systems will play a increasingly crucial role in enabling innovation and automation across the various domains. So at the end of this video, as we conclude our exploration into the fascinating world of embedded systems, I hope this journey has been as enlightening for you as it has been for me. Reminder, knowledge is power, and understanding this technology that surrounds us empowers us to innovate and create. If you found this video informative and engaging, don't forget to give it a thumbs up and share it with your friends and colleagues who might also benefit from this knowledge. Subscribe to our channel to stay updated on future videos exploring the latest advancement in technology. So thank you for joining us, and until the next time, keep exploring, learning and creating.